Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This video is part 2 for image classification project using TensorFlow. Let's continue. You will require TensorFlow, NumPy, Matplotlib for this project. You will require datasets, layers and models from Keras. Then comes the part of the dataset. You don't have to download the dataset manually from any website. To download it, it will automatically, so the dataset is already available in Keras. So the CIFAR 10 dataset consists of 60,000, but this time 32 by 32 color images. So if you remember, in the previous MNIST dataset we were having digits in the black and white or grayish format, but this time in this dataset we are having 60,000 32 by 32 color images in 10 classes. So there are 10 classes, different classes available here with 6,000 images per class. The classes are, which images are available: airplanes, cars, birds, cats, deer, dogs, frogs, horses, ships, trucks. So these are the available classes in this dataset, and they are in color. So what you will say in technical terms: RGB, red, green, blue, 3 color channels. It contains 3 color channels. This is in technical term how you say color images. And the list of 10 different classes are these, and there are 6,000 images per class. And I told you in previous sessions also, so whenever we talk about datasets, then we will distribute the dataset into two parts: one for training the images and another one for testing the images. So whenever we work on machine learning algorithms, then we will distribute the data to two parts. This allows you to train your model on the training set and evaluate it on the test set. Then comes the task. So the task is, the goal with CIFAR 10 is to build a model that can classify the images into one of the 10 classes. So as you can see, this is the code. This is how you distribute the data in two parts. And okay, so let's see. To visualize the data, so mention the class names in the code like this, and this is how you subplot the data, if you remember from previous sessions. So this is how subplot looks like. So multiple charts will be plotted on the same screen. This is what subplot is. Okay, so now comes the part of building the CNN model. So the process is simple. Just remember what we are doing, and the process is simple. So this is the code: models.sequential, and this is first layer, second layer, third layer, and then comes the flatten the output and fully connected layer at last. I will tell you how to read this and what this means here. Okay, so the create the model. Model is built using the sequential class, which allows us to stack layers one after the other. So simple. This is how you create a sequential this is how you create a model object. Then comes the first layer, convolutional layer, and now look at this, how you read this. The first layer with 32 filters. First layer with 32 filters, each of 3 by 3 size. So this is how you define it. So the first argument contains what first argument is 32 filters. Second comes the size 3 by 3. It uses the ReLU activation function. The input shape, what this means is input is 32 by 32 pixel image with 3 color channels. 32 by 32 with 3 color channels. This is how you read. So you have 32 filters, each of size 3 by 3. Then you have input is 32 by 32 pixel image having 3 color channels RGB. This means this is color image. What this line means is, after this we add max pooling to reduce the size of the feature maps and keep the most important information. This max pooling layer reduces the size by half. What will happen after this? It will reduce the size by half. So you understand the computation. If you are doing 1 GB, you have 1 GB, you are now require only 512 MB, like something like that. So you can reduce the size by half and keep the most important information that is required for the detection. This is what first layer will do. So now do you understand what first layer is doing? Okay, so let's look at the second one. What is happening, how to read this. Second layer has 64 filters. So earlier we were having 32 filters, now we are increasing the filters. We have now 64 filters, again with 3 by 3 size, and uses ReLU activation. Another max pooling layer is added to further reduce the size of the feature map from okay. So again we are reducing the size. So because we are using 64 filters now, we can go for reducing the size. Then comes the part third, convolutional layer, third one. So again we have 64 filters, no pooling is applied after this. So the output, so here we are not reducing the size, not applying the pooling, but we are just using the 64 filters. Now one question arises, why are we using multiple filters? So when the data passes from layer to layer, so we will get some idea of the data from first layer, then again more idea from the another layer, then more idea from another layer, and from these 3 layers we will collect the data to make some decision in the next layer. So if you remember, I told in these layers, convolutional layers, what we are doing is we are trying to capture different features such as edges, texture or other patterns. This is what we are trying to do. Instead of using only once, we are applying this 3 times so that we can get more data. So as you know, it contains 60,000 images. So if we compute using only one layer everything, then things will get complex and we will require more compute power. So this will be the technique. You can break down into 3 parts and still get the same output available. So this is how layering works here. And then comes the part of flatten and fully connected layers. This is how you flatten the data And if you remember why we flatten the data, this is why the flattened layer turns the 3D output. So as you know, after the computation we will get a 3D output because there are multiple layers available, so we will get a 3D output. So what happens is output of the last layer into 1D vector. So we are converting it to 1D vector. Why converting it to 1D vector? This is necessary for connecting it to fully connected layers. So you won't be able to work on fully connected layers if you have a 3D data and not the 1D vector. So you will require 1D vector if you want to connect with fully connected layer. If you want to work with fully connected layer, go for 1D vector. You don't have to do things manually. Everything is available on the code level. Okay, so how to read this code? What is happening now? Dense layer with 64 neurons and ReLU activation is added. This layer learns complex pattern from the features extracted by the convolutional layers. Finally, the last dense layer has 10 neurons. Finally, the last dense layer, again 2 times. So the last dense layer has 10 neurons. Why? Because we want output in 10 different classes. This is the same thing that we did in previous session also, as we were working with digits. So from 0 to 9 we had 10 different classes. Here also we have 10 different classes. If you remember on the code level, these are the 10 classes that are available in this data set. So this is the reason we are putting here a 10, but no activation function is applied. This is often followed by softmax during training to convert the outputs into probability, but here no activation function. This is just for the output, sensible output that we want from this project. Okay, I will not tell you part 6 today, but I will show you the run the final project and show you how it works. So I will just run this and see the steps, the final output, the charts. Let's look at this. Okay, in the first step it will show you the 10 classes like this. This is the first step. When I close this, it will show you so this is training process. It is training the model. This is the training process, epoch 10 till epoch 10. So this will take time. This is epoch 1, so you understand this will take some time, and I have mentioned everything in the article, but I will tell you to compile the model and how to read this output. I've included everything in the article, but I will tell you step by step in the next session. Yeah, one more thing. The time taken now is more because I am running this on CPU. If you run on GPU, it will train the model within 30 seconds or 40 seconds. I have tried this on Google Colab, and I think it took 30 to 40 seconds. So as you can see in this output, accuracy is increasing, and loss, we have some loss. So accuracy is increasing. This is important. So you can see the chart is going up like this. So this is good. We have loss here, but we also have accuracy. Okay, so let's see. So this will be the plot. It will show after the training the model, and when I close this, I will get this one more chart. So what epochs are? Just the multiple passes. So as you know, we gave the 10 passes. So what happens? See, so the loss is going down and down or reducing like this with each pass. This is how you read this. Loss is decreasing, and when I close this, yes, so at last it will just show the test accuracy like this, and these all details I have included them in the article, and in the next session I will tell you how to read this. So the project is again for detecting the image or classifying the image. So suppose you have 1 million images on your computer, or you want to create a robot that can detect the objects in the real world. So you will require these kind of models for object detection or classification. You will require these kind of models. I will continue this session in next video. See you in next video. Have a nice day.